layer 2 security mechanisms, and layer 2 management. All right? Layer 2 security mechanisms and layer 2 management. This is also a new chapter that we added. It's actually not really completely new. It's something we moved over from IC&D 2 because they moved a lot of the security stuff over to IC&D 1. Okay? So, we know how switches work, right? Switches build something called a MAC address table. And that MAC address table is built dynamically as frames pass through the device. We talked about that yesterday, right? What is stored in a MAC address table? What is referenced in the MAC address table? Any ideas? Can you guys visualize that? If I said, tell me what are the 4 things that we see in a MAC address table, what would you say?
Port.
The port, the physical port, the MAC address.
Would be
the VLAN, and whether or not the MAC address was static or dynamic, right? So those are the 4 things that we'll see. If you go into your switch and packet tracer, you do a show MAC-address-table. So I go into my switch here, show MAC-address-table, and there are the 4 things that I was talking about. The VLAN, the MAC address, the port type, and the port number. Okay? The type would be simply, I mean, in most cases it would be dynamic anyway, right? Because these MAC addresses, or this table is being built dynamically. And as the switch, by the way, what does the switch use to build this information? It's using the information that it receives from a frame, right? It's more specifically the source address of the frame. We talked about this yesterday. So switches automatically populate their MAC address table by watching traffic that enters the ports. And then a switch will forward traffic through all the ports if it can't find the destination in the MAC, or it can't find the destination MAC address in the CAM table.
I have another question, because in our little network here, we got a PC connected to the switches. How come the PC information doesn't show up?
Because the entries in the MAC address table are only there for a period of time. If I haven't heard any traffic from the PC in a certain amount of time, then that entry gets deleted. If you were to generate traffic again, then you would start to see the PC in there again. That make sense?
Yeah.
So if you do a couple of pings from your PC, you'll see it in there. All ports except the port the frame arrived on if it can't find the destination MAC in its CAM. There, that's better. Okay? By the way, that's called flooding, right? So we know how a switch operates. Switches forward traffic to all ports except the port the frame arrives on if it can't find the destination MAC address. In other words, if the MAC address hasn't been learned, we flood that message. Under these circumstances, the switch acts like a hub. And whoever's connected to that switch can then see that information. So what we're talking about here is the way a switch operates if it hasn't learned anything, right? Now an attacker can exploit this behavior to gain access to traffic that would normally be controlled by the switch by using something called a MAC flooding tool. Now here's how it works. Essentially what the attacker does is it creates or generates a large number of frames with bogus source MAC addresses. All right, we generate a large number of frames with bogus source MAC addresses. Now the idea here is that we are flooding the switch with a bunch of bogus information so that we can fill up the MAC address table or the memory with a bunch of bogus information. All right? Now eventually that table fills up, and any legitimate frames that pass through that switch don't get learned. Okay? Legitimate frames don't get learned. So now for all of that legitimate traffic starts to get flooded, and now I can start to get copies of that information. All right, so let's say you're the attacker on a switch, and you want to see all the data that he's getting. Now by default, once the switch learns his MAC address, the data only gets forwarded to his port, which means you'll never see that information. That make sense? So what you want to do is you want to flood the MAC address table with a bunch of bogus MAC addresses so that when he sends a frame to the switch can't add his MAC address to the database because it's full. But that doesn't mean he stops working, because whenever somebody sends a frame to him, because his MAC address is in the table, we just flood that information. Now you get a copy of it and he gets a copy of it. Does that make sense?
When does the switch purge the table?
Over time, right? Once MAC address entries are in the table, they stay there and for a certain period of time. We don't ever purge the table if the MAC addresses are active, right? So this is a specific type of attack that allows us to take advantage of what a switch does. Now, just because a table is full doesn't mean the switch all of a sudden stops working. It just simply doesn't add new entries. So all of those legitimate entries that are not being learned, that traffic gets flooded. Okay? Now we're going to talk about how we can stop that from happening a little bit later on. We need to disable unused ports if, well, I don't know that this is a best practice standard. It's certainly something that we would consider doing. Disable unused ports. Switch ports by default are turned on. So one of the things that you can do to protect yourself is to shut down those unused ports. We don't usually do this as a best practice standard. I don't usually do this. We'll just simply not have any kind of cables plugged into those ports. And then when we want to utilize the port, then we'll plug something into it. Okay? But how can I stop a MAC flooding attack if the port is already active? You're a legitimate user on the network. You're disgruntled. You're pissed off. You didn't get the raise. So now you want to hack the network and screw with people. But you're a legitimate host on the network, so you have to be connected to the network. So we have to be able to protect our network from these types of attacks, and shutting down the port is simply not an option, because then that means you're not attached to the network. So one of the options that we have is to run a feature called port security. Port security allows us to control or limit what MAC addresses are allowed on a particular port. Okay, now there are three ways that we can implement port security. We can implement it using static MAC addresses, we can implement it using dynamic MAC addresses, or we can implement it using a sticky feature. Okay? Let's look at the second bullet point before we get down to that point. When a secure dynamic port option is enabled, when the secure dynamic option is enabled, we specify the maximum number of MAC addresses that are allowed on a port. And if the maximum number of MAC addresses is reached, then that causes a violation once we exceed that number. So think about what they're saying there. They're saying, okay, I'm going to go ahead and set up port security on this interface. Your interface, for example, to protect against a MAC flooding attack. And I'm going to say for your particular interface, I'm only going to allow 2 MAC addresses. So as soon as you start injecting a bunch of random MAC addresses, once you get beyond 2, that causes a violation. and we can identify that violation and perform some action based on that violation. Does that make sense? All right. So let's take a look at the three options that we have for configuring port security. Static, pretty simple to understand. With static port security, all we're simply doing is identifying specifically which MAC addresses are allowed on which ports. Literally specifying the actual MAC address that's allowed on the port. So if I know the MAC address of your host, I can go into the port that you're connected to and I can say, only allow this MAC address on this port. Okay? That is static port security. Dynamic is different because in dynamic port security, I'm not concerned about the MAC address specifically. I'm only concerned about the number of MAC addresses. So again, I go to your port, I say, look, I don't care if it's your machine connected to this port or if it's somebody else's machine. But regardless of whoever's connected to the port, I'm only going to allow X number of MAC addresses. So you can have your laptop plugged in, you unplug, somebody else comes and plugs in, it works fine, but I'm not going to allow more than one MAC address or more than two MAC addresses on the port. So if somebody starts flooding that port again with bogus MAC addresses, a violation will occur. Yes?
So if you plug one device into that port, they work, they unplug, somebody comes by and plugs in their laptop, or they do something, they unplug, and let's say you got it set to, a third person comes and plugs theirs in.
Well, but every time the status of the port changes, the MAC addresses get cleared out. So if he's plugged in and he unplugs, his MAC address gets cleared from the port. Somebody else comes and plugs in, and they unplug, their MAC address gets cleared from the port. But when will that not occur? If he gets a hub or a switch and plugs it into the port, and then starts plugging devices into that hub or switch, the status of the port's not changing. So now he's plugged in, somebody else is plugged in, that's when a violation can occur in a dynamic scenario. So remember, static is where I'm actually specifying the actual MAC address that I want to allow or disallow. Dynamic means I don't care who the MAC address is. I just care about how many there are. Does that make sense? Now, sticky is kind of a combination of both. Sticky starts with dynamic and ends up being static. We'll see more about sticky in a little bit. All right? Basically what happens is with sticky is whatever MAC addresses are learned get written to the port. So you may not know what your MAC address is, but you say, okay, well, go ahead and plug your machine in. I have the port set up for sticky. As soon as you communicate, your MAC address is written to that port. Okay? So those are the three options for port security. We're, of course, going to take a look at the configuration of these, and that will hopefully make it at least a little bit more clear. All right? So obviously with port security, we're trying to prevent or we're trying to mitigate some sort of attack vector, right? And typically that attack vector is either rogue devices on the network. What's a rogue device? What is the definition of a rogue device? A device that's not permitted, a device that's not allowed, a device that's not authorized, right? So the whole point of port security is either to prevent rogue devices from being attached to the network, prevent some sort of MAC flooding attack or some sort of attack vector using MAC flooding, or to prevent somebody from either plugging in their old laptop or additional devices on the network that you may not be aware of, okay? So obviously the whole point of setting up security is to also identify when there are breaches in that security. And one of the things that we can do when we see a breach is we can take an action. And that action might be to turn the port off, or it might be to generate some sort of log message or some sort of alarm. All right? There are actually 3 different actions that we can take. We call these violation modes. A violation mode is essentially what action do I take if there's a violation on the port. Now, the default violation mode is to shut down the port. So it doesn't matter what the policy is, whether it's sticky, static, or dynamic, if a violation occurs and you have the default violation mode of shutdown, the port goes into something called an error disabled state, meaning that it essentially virtually shuts off. Okay? There are 2 other violation modes, restrict and protect. Now, in both cases, restrict and protect do the same thing. They block the offending host. What do I mean by that? They block the offending host. What do I mean by that?
It blocks the sending traffic from that, the device that has that host name, that MAC address.
Right. So let's say, for example, I've set a violation, I've set a dynamic port security to allow for 3 MAC addresses. Okay? But a 4th MAC address shows up on that port. The first 3 MAC addresses are not affected by the violation. Only the 4th MAC address is affected. Okay? Both restrict and protect do that. They only block the offending host. They do not block the hosts that are not violating the policy. Okay, so why have 2 different kinds? Well, it's simple. Restrict blocks the offending host, but it also generates error messages. It generates alarms. It generates events. Whereas protect doesn't generate error messages. It doesn't generate alarms, and it doesn't generate events. So that's the only difference between these 2 modes. They both block the offending host, but restrict generates these messages and increments the security violation counter, whereas protect does not. Okay? Now, out of these 3, the one that I tend to use the most is restrict. Because I don't want to create this environment where I have a denial of service attack on myself, where somebody knows that port security is configured, and if they violate the policy, the port shuts down, which affects the normal users on that port as well. So I'm going to go ahead and use the restrict option because I only want to block the offenders. I don't want to block the regular users that are not violating the policy. Does that make sense?
But if he's sending out those bogus,
He's going to be the offender.
right, but he would be he'd be the first MAC address that would be connected, right?
Okay. He would, right? But if he's starting to send out a bunch of bogus MAC addresses, his original MAC address might still be allowed, but all those bogus MAC address entries would be denied.
Right.
Which means we effectively blocked his attack, right? Now, we haven't blocked him necessarily, but we've blocked his attack. Now, if I had the shutdown option, obviously it would block him as well, right? Okay, it just depends on what your overall objective is. If your objective is to mitigate the attack vector, not necessarily concerned about him being an attacker, but simply mitigate the actual vulnerability, then a restrict option is okay. If your objective is to say, if there's any potential violation, we're just going to block the port and figure out what's happening, then use shutdown. Just depends on what your goal is. All right?
Everywhere I'm going to deal with you shut down.
Yeah, a lot of people do use shutdown. And that's because if a violation occurs, they want the administrator to be able to go identify what that violation was, why it occurred, and so that they can take even further action, maybe identify the user that's creating that violation and tell that user, hey, you can't do this. you know. All right. All right. Let's take a look at some of the defaults, and then we'll take a look at some of the configurations. When port security is enabled on the interface, there are two defaults you're going to have to know about. Number one, the maximum number of MAC addresses that's allowed on the port is 1, and the violation mode is shut down by default. In addition, the default mode is dynamic. All right, we don't see that listed on the slide here, but the default mode for port security is dynamic. All right. Maximum number of MAC addresses is 1, and the violation mode is shut down by default. All right, there are a couple of other restrictions as well. Port security cannot be a span destination port. We don't know what span is yet, but we're going to see span a little bit later on. Actually, we also don't know what ether channel is, but we're going to see ether channel a little bit later on as well. Both span and ether channel have been added to the courseware. Wasn't originally included as part of the course, but it's been added. Okay. If you have a voice VLAN, make sure you set the maximum allowed secure addresses to 2 plus whatever you're trying to allow, because a Cisco phone requires 2 MAC addresses. 1 for the phone and 1 for the switch that's built into the phone. All right, so if you want to allow a host plus a phone, you need to allow up to 3 MAC addresses on that particular interface. All right, now the other thing that I did for you guys in the courseware here is I gave you, essentially I just gave you the raw syntax for port security and what those commands are used for. We're not going to go through each of those individually. That's for your information. We are going to look at some configuration examples though. All right, so let's go over to slide 147 and take a look at some configuration examples. The raw syntax is just there for future reference. Okay? So here we go. We're going to set up port security on our switch. We go into configure terminal, which is global configuration mode. I go into the interface that I want to establish port security on. The first command that I have to do is I have to disable the dynamic nature of that port. Now, that's the command switch port mode access. Now, switch port mode access is a command that we're going to talk about a little bit later on. It's actually not directly related to port security, but it is required for you to be able to configure port security on an interface.
What is it that it disables?
It disables the dynamic nature of a port, specifically a protocol called DTP. So it doesn't have anything to do with port security specifically, but it is a requirement for port security. A secure port cannot be a dynamic port. And that's all I'm going to say about that right now, because we're going to talk about DTP later on. Just know that that is part of the configuration that's required. The rest of the commands are pretty intuitive, right? What does switch port security maximum 5 do?
Maximum of 5.
We're going to allow 5 MAC addresses on this interface. Exactly. The default is 1. I'm overriding the default by allowing 5. Pretty simple. What about switch port security MAC address sticky? I'm setting the mode. I'm setting the mode. Okay? I'm setting the mode. In this case, we're setting the mode to sticky. Do you guys remember what the sticky mode does? What happens in sticky? It starts as dynamic, but as soon as somebody communicates on that port, their MAC address gets written to that port in the running config. At the bottom of the slide here, you can see the result of a host communicating on that port. This command that you see here under the show run interface, that's not something that you added as an administrator. That was added by the switch automatically. That was added by the switch automatically. So that's what the sticky feature does. is it takes any dynamically learned MAC addresses and it writes them to the port, which becomes static, right? And if you save your configuration, then that's permanently written to your configuration. So where would be a good example where I might use this sticky feature? Let's say my goal is to implement port security, but I don't want to go around and identify everybody's MAC address manually. So what do? I configure sticky on all the ports. I verify that the devices that are attached to my network are correct, and as soon as they start communicating, their MAC addresses get written to the port. So that I don't have to go and learn them. All right. Port security on a trunk.
If you interchange devices on there, will each one persistently get written?
Up to the maximum, yes. Up to the maximum. Once the maximum has been reached, no more will get written, because then there'll be a violation. And by the way, in this case, the violation mode is shut down because it's not specified. As far as defining port security on a trunk, you can. You can enable port security on a trunk, but you would not enable port security on a trunk that goes to, say, another switch. You would enable port security on a trunk that might go to like a VMware server or a router on a stick or something like that, where you know there's only a certain number of MAC addresses that are going to come in. But you would not configure port security on a trunk interface that goes to another switch, because you don't know really how many MAC addresses might exist beyond that interface, right? You could have potentially thousands of MAC addresses that will come across that trunk. But remember, there are other uses for trunks than just connecting switch to switch. We use trunks to connect to VMware servers, we use trunks to connect to routers, and so on. Okay? So it is possible. You would just simply say switch port mode trunk, and then instead of switch port mode access, and then you can start to configure your port security. Now, the last command that we see there, switch port security. That command is what actually turns on the feature. You can do the other commands, but if you don't put in that last command, port security is not actually activated.
Does that have to be the last command?
It doesn't have to be, but it's generally recommended, because if you make it the first command, what's going to happen?
It'll automatically start.
It'll start running port security with the defaults, which is a maximum of 1 and dynamic. And you might already get a violation if you already have 5 hosts connected to that port, right? So I generally like to do that command last. To turn off port security, I simply do no switch port security. I don't have to remove the other commands, because if the feature's turned off, the other commands are irrelevant. Okay? How do I verify whether or not port security is running? I do the show port security interface command. For this particular interface, I can see that port security is enabled, the port is actually active, the violation mode is shut down, which makes sense because I don't see a violation mode specified, so we know that it's the default. The maximum number of MAC addresses allowed is 5. The total MAC addresses is 1, which is a sticky MAC, and it's the 0601 address. So I have 4 more hosts that can communicate on this port. As soon as the 6th host tries to communicate, the port will shut down. Okay? Another example, switch port mode access, switch port security maximum 10. So we know that that sets the maximum number of MAC addresses to 10. Switch port security MAC address 000000000003. What did I do with that command? That's a static MAC. It's not sticky, it's static, right? I went ahead and I manually identified a MAC address that's allowed on that interface, which means how many dynamic MACs are left? 9. I used up 1 slot for a static, the other 9 are sticky. Okay? In fact, The bottom table shows us that the 0003 MAC was secure configured, meaning that it was static, and that 0001 and 0002 were secure sticky, which means they were learned dynamically initially, and then they were stuck to the port using the sticky option. Make sense?
Does that change after a while?
Does what change after a while?
The secure sticky change to secure configured?
Nope, secure configured means you as an administrator configured that MAC address on that port. Secure sticky means that the MAC address was learned through the sticky process. And then, of course, those MACs get written to the interface. There should be a sticky in these two commands, but that's okay. These two commands you did not put in as an administrator. These two commands were entered, there should be a sticky keyword there. They were entered from the sticky configuration. Okay? So there should be, the sticky keyword should be right here in between. Right. You should see sticky there. All right. Now, another method of securing ports is to use something called 802.1x. 802.1x is an IEEE standard that allows us to apply something called network access control or port-based network access control, which means that when the device attaches to a port, this has nothing to do with port security, by the way. This is another way of authenticating users to a port, okay? So you take your laptop, you plug it into an interface. If that interface is configured for 802.1x, which we're not going to look at the details of that because it's beyond the scope of this class, but if that interface is configured for 802.1x, what's going to happen is the switch is going to send a message to the host saying, you need to authenticate to be able to access this port, okay? That authentication is called the Extensible Authentication Protocol, or EAP. Windows and Linux and Macs, they all have these 802.1x clients built into them. So if you have 802.1x identified on a port, then the laptop or PC has to be configured to use 802.1x to authenticate. And it is literally authentication using a username and a password. Okay? So if you can imagine, PC plugs into the port sends a message to the PC saying, you need to authenticate using EAP. You have your EAP client configured on your laptop that says, okay, a window pops up on your machine for an authentication for your credentials. So you put in your username and password. Then that username and password gets sent to the switch. What the switch does is then passes that information on to a server, Radius or TACX, usually Radius, passes it on to a Radius server, authenticates the user, and then once the port is authenticated, then the port becomes active. Does that make sense? And it's actually much more involved than that. You can even have it dynamically assign a VLAN to that port. You can have it put access lists on the port based on the user's authentication credentials. There's a whole bunch of things you can do with network access control. The reason this slide is here is because they do talk about 802.1x on the test in a very, very high level. Basically, what is 802.1x, right? You guys probably saw that question in the review. Okay? We could spend 3 or 4 hours talking about network access control, but we're not going to. Okay? There is a Cisco product that integrates this .1x security called ICE, the Identity Services Engine. So it takes 802.1x and it basically incorporates just a whole bunch of other things like posture assessments, the ability to scan a device and identify whether it has the appropriate antivirus software or if it has the appropriate security on it. And then we can essentially make a decision to authenticate that user based on that. Okay? Last thing we'll talk about in this chapter is the Cisco Discovery Protocol. You guys have probably utilized CDP at one point or another in your life. CDP is a layer 2 protocol primarily used for management, but it's not only for management. For example, a Cisco phone will use CDP to identify what VLAN it belongs to. A Cisco phone will use CDP to identify how much power is necessary. Okay? Phones require power. Some phones require more power than the other phones.
If you're not using a device that requires power, will you see that information doing a show CDP neighbor?
No, you wouldn't see that information. CDP is primarily used today to identify directly connected Cisco devices, right? And again, that's not its sole purpose, but it is one of the primary uses of CDP today. For that reason, because CDP does allow us to identify what types of devices are attached, what version of software they're running, what IP address they might have, CDP can be considered to be a security risk. So in some cases, you may want to disable CDP. We'll talk about how we can actually enable or disable CDP a little bit in a next slide or two, okay? So how does CDP work? Well, first of all, it is a protocol that sends out frames every 60 seconds. So every 60 seconds, CDP devices, and by the way, this is not just Cisco now. HP supports CDP. A lot of other vendors are starting to support CDP natively, even though it is a proprietary protocol to Cisco. There is an open standard version of this protocol. It's called LLDP, the Link Layer Discovery Protocol. But for the test purposes, you guys need to know about CDP. All right, so we can see that CDP is being sent out every 60 seconds. We have something called a hold time. Do you guys have any idea what a hold time represents? What does a hold time represent? A hold time is how long I'm going to keep information in my database if I'm not receiving any advertisements. After the hold timer expires, it's a countdown timer. After the hold timer expires, if I haven't received any messages, I'm going to delete that device from my list. So for example, R4. We can see there's a hold time of 166 seconds. If I don't get a CDP advertisement from R4 in 166 seconds, I'm going to delete R4 from my database. Okay? So R5 has how many directly attached Cisco neighbors? 2, right? Switch and R4. The device ID is the host name of the neighbor. The local interface is the interface that I go out of to reach that neighbor. The hold time is how long I'm going to keep that neighbor in my database if I don't get a CDP advertisement. By the way, that hold timer is 180 seconds. So I should never really see that number go below 120 seconds, should I? Because every 60 seconds I'm getting an update. So whenever I get an update, that hold timer goes back up to the maximum value. The capability is what the platform is, a switch or router in this case. The platform is the model number, and then the port ID is the neighbor's interface that it uses to get to me. That make sense? So one of the things that CDP provides you the ability to do is map out your network, assuming you have all Cisco devices. You can easily map out what devices are connected to what. So for example, if I come to this device, show CDP neighbor, I can see all kinds of devices attached to this device. And I can see things like access points, routers, phones. Here's one that there's a phone connected to port 7. There's a router connected, a 3850 switch connected to port 2. There is a Cisco Unified Communications Server connected to port 3 or port 14, excuse me, that's a VMware server. There's an access point connected to port 103. So all of my Cisco devices are going to run this protocol. And it's a nice, easy way for you to identify what types of devices are connected to your device. But because it does give you that information, there may be times where you want to disable CDP. All right. In addition, we see here, if I do a show CDP entry, I can see the details for a specific entry. By the way, when you're using the show CDP entry command, you put the name of the device as what you're trying to look at. Okay. So let's say, for example, this building 2 switch 1, I want to see the details for this guy. I'll do a show CDP entry, and then I'll put in that device's name, and then I can see the specifics of that device. Things like what type of device it is, what software it's running, what release it's running, how long the device has been active, what version of CDP it's running. If it's running VTP, what VTP domain is it in, and so on. Lots of information. Now, because this information is being provided through CDP, you may want to disable it. There are 2 ways to disable CDP. You can disable CDP globally by doing the no CDP run command. No CDP run disables the CDP globally. You can see that in the first box. That means that every, CDP essentially is not running on that device at all. Or you may want to simply disable CDP on a specific interface. Maybe it's an interface that goes to a service provider, or an interface that goes to a device that you don't necessarily trust. So you might want to disable CDP on an interface. The no CDP enable command disables CDP on a specific interface. Okay? All right. All right. That is the end of that chapter. When we come back from lunch,